Let's begin looking at a trapezoid here in this lesson. We are interested in its area and its perimeter. And the perimeter is not going to give us any trouble. It's the area that we're going to have to work for here. Let's look at this trapezoid here. It's a quadrilateral, ABCD, and the trapezoid is defined as a quadrilateral having exactly two parallel sides. These other two sides here are not parallel. If they were, then it would be a parallelogram. So this is a trapezoid. Now the first thing I'm going to do is take, you can imagine this book here, take this, flip it, and flip it this way. So you flip it twice, you do this and then that, and you move it over here. Now if you jam those together, can you see that that makes one giant parallelogram? Okay? So the area of this thing, whatever it is twice the area of the original trapezoid. So we'll just remember that. It's twice the area when we get done in a minute. All right, so what is the area of this big one here? Well, if we call this base, and let's be consistent with our drawings here in your paper that you're going to look at, we call this B sub 2 and B sub 1. Those are the bases, and by the way, these are the legs. And so B1 up here is now transferred down here, and we do all this flipping, and so the base here of this thing is B sub 2 plus B sub 1. All right, then we could talk about, I don't care where you put it, some perpendicular like this is the height, and it's also the height of this. So the area of this thing here, this massive parallelogram, is the base, as we've learned to do before, times the height. But this is the area of the parallelogram. Let's put a sub P there. The area of our trapezoid we were originally interested in here is half of that. So it's half of this. Let's just write it this way. Now here's the way I like to think of it. I like to think of this piece here as being the average of the two bases. That's exactly what that is. When you add two things together and divide by 2, you're averaging them. So looking at this original trapezoid, we want its area, average these two bases, multiply by the height, and you've got it. That's the area. Of course, the perimeter would be all four sides added together. In these examples, we're asked to do this, to find the lengths of the two bases, and often that's just given. You just look at it, write them down, and that's the case here. The height, the two bases, the height, and the area of the trapezoid. All right, so this one was given as 10. Now this is given, all that information right there. And so B1 is equal to 12. And by the way, it doesn't matter what you call B1 or B2. Either way, it's fine. B2 is 10. And the height is this perpendicular distance that we see right here. That height is 5. Now, what about the area? Well, the area of the trapezoid is 1/2 the two bases added together, so that's 10 plus 12, times the height, which is 5. So let's see what we're going to get here. This is 1/2 22 times 5, so it's 1/2 of 22 is 11, and 11 times 5 is 55. So there is the area. So we have the base, the other base, the height, and the area. Okay, on example 2, just a little work to do. It's not going to be as easy as the last one. Most notably, the height is missing here. So what we need to do, the very first thing is come up on the side over here, redraw this little triangle right here where this is 60 degrees. We're going to find the height. This little piece down here was given as 4. So here's what we're going to say. I think we need to use tangent because of an angle, the opposite and the adjacent side. That would call for tangent. So the tangent of 60 is the opposite over the adjacent. Cross multiply, h equal 4 times the tangent of 60. We work all of that up on the calculator, and here's what I get when I do that on my calculator, 6.9282. That's h. All right. Let's see if we can find the area now. The area is, how do we find that for a trapezoid? It's 1/2 the product or the sum of the two bases. So this bottom base here is 14. 10 plus 4 is 14. This other base is 8. The height we just found is this. And so if we run all of that through the calculator, it should give me 76.2102. Now, we should be circling all our answers here, and we were asked to get the height, the area, and we're also asked for the two bases. And it doesn't matter which one you call base 1 or base 2. So here's 14. Remember, that was 10 plus 4. We got that one. And base 2, this other one, was already given as 8. So there's all 4 things that were required of this problem. Well, here we go. This one's going to be a fun one. In addition to finding the two bases, the height, and the area, guess what? We also got to find the perimeter on this one as well. So I think the most critical thing for us to find is that height. Now if you'll notice, this is a right angle right here. So this height here that we find is automatically that side, and that's going to help us find the perimeter in a minute. I think we desperately need to work with this triangle over here. Now what I've done here, I'm going to call this side X because we're going to need to know it. To find the perimeter, we're going to need to know that side. And this side, of course, I'm going to call H because that's the height of this triangle. So if this is 45 degrees, then let's see what we know here. How long is this little piece? Well, that little piece is this entire 20. Now remember, this before I started labeling this in here, this whole side was 20. And so 20 minus 15 tells me that this side is 5. It's a little misleading when you see the 20 in there like that, but before we start drawing all this stuff, this whole side was 20. All right, so how are we going to do this? Well, hey, if this is, let's do this the quick way. If this is 45, this is 45. That's an isosceles triangle. Both sides are equal, so that's 5. This side is 5. Now you can do it with trigonometry, and I did in the notes here. I did it with trigonometry, but that's the quick way. Both legs, they're equal. It's isosceles, so that one's 5. Now you can get the x with the Pythagorean theorem like this. You can say x is the square root of 5 squared plus 5 squared. So that's the square root. 25 plus 25 is 50. And if we do that on the calculator, that x is, let's see what I got here for the x. Here it is. It's 7.071067. That's about right. Now think of reasonable. Does that sound right? Well, 7 times 7 would be 49, so that's just a little over 49. That looks like a reasonable square root. All right. I think we're ready to start making some progress here. This is one of the things we'll circle. One of the other things that we'll give is the base down here was 20. The top base is 15. So the area of this thing is 1/2 the sum of these two bases times the height, and the height there is 5. And if we run all of that through the calculator, this is what I came up with. Now you try it on your calculator, but I got 87.5. Now the perimeter, well, we've got everything that we need to do the perimeter. There's 15. This side here is that H, which is 5. This side here is 20. And here's the weird side, X, is this number here, 7.071067. And all of that stuff added together, if we run that through a calculator, I think you'll get this, 47.071. Give it a try and see if that's what we get, okay? There's our answers. Now we come to something pretty important at the bottom of page 2. There's a box there, and I want you to take these notes with me. The first thing let's do together, let's draw a trapezoid that looks something about like this, okay? And let's call this B1 and this B2. And let's show the midpoint of that side and the midpoint of that side. And let's join those with a little line segment. Now that is known as the median. That's the median of this trapezoid. And here's a fact that we're going to state. The median of the trapezoid is equal to 1/2 of base 1 plus base 2. It even looks like it is. Now look, that means it's the average. This is the average of the two bases, and that looks about right. So, if we flip to the next page, here's another formula for the area of a trapezoid. Now remember, the formula we developed earlier for the area of a trapezoid said this. It was 1/2 the sum of the two bases times the height. The median is 1/2 the sum of the two bases. Now if we put those together, then we have us a new formula at the top of page 3 for the area of a trapezoid. It's the median, the length of that line segment there, times the height. We got us a new formula for the area of a trapezoid now. Example 4, interesting figure. Yeah, that's a trapezoid. I mean, they're both sort of leaning in the same direction, but we only have two sides that are parallel. And so it's a trapezoid. Now notice that we have a median. How do I know that's a median? These two segments are equal. See the little tick marks? This is parallel. And we even have these two marked as equal. So it is a median, and we can use its length, which is given in this figure is 52. We can use that length to help us find the area. Now we would not get anywhere except, unfortunately we're given the height here. So to find the area, this is going to be real easy. It's the height. It's the median times the height. Well, the median is 52. The height is 25. And so we just multiply them and we have our answer. It's 1,300. 1,300 is the area of that trapezoid. Finally, we wrap things up with an easy one here on example 5. If a trapezoid has an area of 79.2 and a height of 4, what is the length of the median? Well, it couldn't hardly be any easier. So the area, we know, is the median times the height. And the area is 79.2 square meters. The median, we want to know the median, so we don't know. Let's just call that M. And the height is given in this problem is 4. So this is all we have to do. The median is 79.2 divided by 4. And we're going to get what out of that? We're going to get, when we divide on the calculator, 19.8 what? Meters. If the area was given in square meters, then this is the dimension in meters here. So there is the median, or length of the median of this particular trapezoid.